Alright, hey there guys. Today we're going to talk about how to do composition of functions. And composition is essentially when you're taking one function and plugging it into another one. There are two different ways that we can write this notation. The first way is this way with the little open circle, and that's f of g of x. The other way is to use two sets of parentheses. Regardless of which way you write this, it still means composition. And the way that we say it is we say f of g of x. So we are taking a function of a function. And when we're doing composition, it's really important to know what the inside function is. In this case, the inside function is g. We're going to start from the inside. The outside function is f. We're going to take g and plug it into f. So we're going to go ahead and take a look at a couple of numerical examples. I have two functions here. F of x is 2x minus 1, and g of x is 4 over x minus 1. And let's start with f of g of 2. We're going to start on the inside, which is g of 2, and evaluate that using our function rule. So this will be 4 over 2 minus 1, which simplifies to 4. So g of 2 equals 4. Then what we do is we take that outside function, which is f, and plug 4 in for x in that function. So this will be 2 times 4 minus 1, which is 8 minus 1. So we end up getting that f of g of 2 is 7. And that's our final answer for that first one. For the second one, we're going to do g of f of 2. So we're going to start with f of 2, which will be 2 times 2 minus 1, which is going to simplify to 3. But then I take that and I plug it into my outside function, which is g. And so now I'm going to have 4 over 3 minus 1, which is 4 over 2, and simplifies all the way down to 2. So g of f of 2 is 2. Now in these next two examples, we have that little circle there. That means the same exact thing as when we have the two sets of parentheses. So don't let that throw you off. Your inside function is still g in this case. So you would start with g of negative 3. In this case, your inside and your outside function are the same. So you would start with f of negative 3, and then whatever you get, you plug it in for f. But I don't want to do all the hard work for you. I'm going to let you guys try that one on your own. So that's how we get composition of functions numerically. So let's go down to example number 2. For example number 2, we have two different function rules now. We're going to start by finding f of g of x, and then state the new domain. So we're always focused on our inside function, which in this case is g. So I'm going to take this entire function here, and wherever I see an x in f, I'm going to plug it in. So it's 4x plus 1, but instead of x, I'm going to write 2x squared plus 5x, and then I have the plus 1. And then this is going to simplify to 8x squared plus 20x plus 1, and I can't simplify that anymore, so I have to just leave it as is. And now we need to talk about the domain. And if we end up with a quadratic, just remember that a quadratic is going to have a domain of all real numbers. So this domain is also going to be all real numbers. Okay? And just kind of like we did with adding and subtracting and all of that, if the original functions have no domain restrictions, when we do the composition, there will be no domain restrictions there either. Alright, so let's look at B. Now I'm doing g of f of x. So we're going to do the same thing now, except I'm going to take f and plug it in wherever I see an x, but notice that there are two x's, so we have to plug it in twice. So this will be 2 times 4x plus 1 squared plus 5 times 2x. I like it. Sorry, 5 times 4x plus 1. This is not working. Okay, sorry about that. I was having some pen trouble, but I have worked it out now. When I do g of f of x, I'm going to plug 4x plus 1 in twice. And so now where this is 4x plus 1 squared, that means I need to actually distribute that out. And that's going to leave me with 16x squared plus 8x plus 1. And then here I can distribute that right away. That's 20x plus 5. And then I'm going to distribute that 2, so I have 32x squared plus 16x plus 2. And then bring down the 20x plus 5. So then my final answer here is going to be 32x squared plus 36x plus 7. And that's my final answer. You do need to think about domain restrictions, but we have ended up with a quadratic. I started off with a linear and a quadratic, and none of those have any domain restrictions. So our domain here is still going to be all real numbers. Okay? And we're going to look at number 3 now. Now for number 3, I want to start off by getting rid of that square root on g of x. So I want it to just be g of x equals x plus 7. So that's my apologies. And we're going to do f of g of x. So I'm going to take this whole function g and plug it in place of x. So this will be the square root of, instead of x minus 9, it's going to be x plus 7 minus 9, which then simplifies into the square root of x minus 2. And that is our simplified composition function, the square root of x minus 2. Now we do need to consider domain restrictions here because this is a square root function. And if you remember, whenever we have a square root function, whatever is on the inside cannot be negative. So x minus 2 has to be greater than or equal to 2. Greater than or equal to 0, which means x has to be greater than or equal to 2. So our domain will be 2 to infinity. Okay? I'm going to let you guys try letter D on your own, but there will be a domain restriction, so keep that in mind. And then for this final one, we're kind of working backwards. I know that I want h of x to be f of g of x, so that means I need to break each of these functions up into 2 different functions. I need an f of x, and I need a g of x. So my suggestion here, g of x is the inside function, that's what we want to start with. If you'll notice, each of these a, b, and c have parentheses with stuff in the parentheses. Whatever is in the parentheses, make that your g of x. So in this case, I want g of x to be x minus 2. Then for f of x, I'm going to leave everything else. I'm going to have that square. And instead of that set of parentheses, I'm going to put an x squared. Because what would happen here, if I were to go evaluate this f of g of x, I would take this expression and put it in right there, which would in fact give me 1 over x minus 2 squared. Okay, let's try one more of those together. For b, I have to find an f of x, I have to find a g of x, and whatever is in the parentheses, that's what you should make your inside function, which in this case is g of x. inside function because that's what they told us in the direction right here. And then f of x, I'm going to leave everything else the same. So I'm going to have a 4/3 minus 2. And wherever those parentheses are, you're just going to put an x in there. Okay, so these are going to be my two functions. I do want to make note that these are not the only two possible functions. Each of these there's maybe a couple different ways that you could do this, but these are two of what I think are the most obvious ones. Okay? And so I've left a couple of these blank for you guys to try, so you can try them on your own and then check them. The answer key is posted on the spreadsheet. And once you finish this, you guys can start your homework, which is the textbook, and I will see you guys on Monday. Have a good weekend.